Look for cover, the nearest cover. Don't try to make it home unless home is the nearest place to go. Don't hesitate. Find cover.
We have to talk about the bug that recently happened this week.
Sounds like you'd be a little more alarmed.
I don't want to give off the impression that it's the end of the world.
I do.
Okay, well, Bitcoin almost died this week. Yeah, so I think to describe this, we need to talk about Bitcoin, and
Sounds
then we can
alright.
talk about what exactly caused like everyone to freak out this past week.
Cool. That sounds like a good one. Is this the Bitcoin white paper? This is Lightning Network.
Nope, it's a scaling decentralized blockchains. But it's a good read.
Cool. Alright. So this problem, let's break this down. We're going to talk about DOS. We're going to talk about the new patch 1.6.16.3.
Yeah, 0.16. Your release is 1.
Oops.
Bitcoin is beta.
Okay. 0.16.3.
Yeah, exactly. That fixes the issue that we're going to talk about.
Cool. And then the last issue is double spending.
Yep.
Okay, so 1, 2, 3. Okay. So this all began with 0.14. So Phil, what's 0.14?
Yeah, so the Bitcoin Core implementation, it implements the rules of Bitcoin in code, right? And it's a pretty popular implementation. It's the original one by Satoshi, and it's run by most of the network, about 95%. So the Bitcoin community discovered a bug, and it affects different versions differently. In 0.14, what was discovered is that if you were to have a double spend within a block, right? So what that means is you have a transaction, but it's being spent twice. This pretty much means, let's say you have $5, you're spending it at KFC and McDonald's at the same time. You can't do that. It's as if you're creating $10 and getting away with it.
And this would cause the nodes to freak out, right? So this guy would be spending this transaction, and the nodes would be checking to make sure everything's okay. And the second they would do that double spend, 2 coins, or same coin being spent in the same block, it would crash the node. Is that right?
Yeah, so in 14, what happened is that a block would be propagated, the nodes would validate that the rules of the block are in line with the network, but they never included any checks so that the node wouldn't crash. It would just crash. So this is called a denial of service. If a miner were to create a bad block and propagate it everywhere, the nodes would process it and crash. The nodes wouldn't pass along the block, but you can take away a big portion of the network doing this attack.
But they fixed it, right?
Yeah. So in 14, the nodes would crash, right?
Mm-hmm.
But in later versions, 0.15 and up to 0.16.2, so the one right before we got this week. So in 15 to 16.2, this issue was fixed. Let's say a UTXO, which is an unspent transaction, was created within a block, right? If it was double spent within the same block,
Then the whole block would be canceled, right?
yeah, so the node would understand and an assertion failure would occur. The code failed to create a sanity check for is, what if a UTXO is created in an older block? So you have, block 1, and the UTXO is being created, and then you have block 2, the one following it, 2 new UTXO that are spending from an older UTXO. You're double spending it, right? The Bitcoin nodes wouldn't catch this, at least 15 to 16.2. So you could have had a malicious miner creating these double spends, and the nodes would just assume that everything was all right. Now, these are only a specific set of nodes. This is where you have serious implications for the network. Thankfully, we know that nobody uses exploit, because if you use the new version of Bitcoin Core 0.16.3 and you sync it from the Genesis block, you would have no failures. Now, if there was a failure at any point during that sync, you would have realized that somebody had exploited this issue. But we know that for a fact, nobody has taken advantage of this.
Cool, so what now, Phil?
We're going to upgrade our node because it's super important.
Dope.
It's time to upgrade our node. We're not going to do it through a binary or a download. We're going to do it by source, compiling it by source. So I'm running my node in on a Raspberry Pi 3,000 miles away. So let me just CD into Bitcoin, right? I'm going to do a git fetch because this is the downloaded straight from the GitHub repository. And I've done it previously, so I have the latest one. So we're going to check out the latest one. Right now we're running, I think, 16.2. And the one that includes the bug fix is 16.3. So we're just going to check it out. Okay. So now we're pointing straight at 16.2. Make sure that you're not running Bitcoin while you're upgrading it. So I'm going to shut it down. I'm also running a Lightning Network node, so I'm going to shut that one down. So let's go ahead and start the process of compiling it. I have to set attributes to my compiler. I may have to do that actually.
Perfect.
So we ran get network info. It will tell you what version you're running. We're running the Satoshi client 17. Yeah, so we're updated. The bug is not going to affect this node. We're going to do a good job of propagating correct, valid blocks to the network and prevent any malicious miners.
Nice.
And yeah, so we're going to share in the wiki how to do this. Also, there's a lot of stuff we didn't get to, like why the bug was introduced, what caused it, and some history, the timeline of how it was found. But we're gonna share some pretty good notes. And we did do like an oversimplification. We didn't show you the code of the bug. There's a lot of cool further reading you can do and learn more.
All right. See you later then.